Okay, for lesson 4 of Unit 0 is kind of a mixed bag of things that have to do with slopes and slope-intercept form and things that are in Chapter 2 of the Blue Book, and also some graphing some linear inequalities on a 2D graph as well as a 1D graph. So anyway, everything you should need is in this lesson. So let me get through that, and so you can handle whatever is coming your way on the test, okay? So warm-up has to do with things that were learned in the class before this. Slope-intercept form formula, the y equals mx plus b, where the m is the slope and the b is the y-intercept. The y-intercept, remember in a 2D graph, this is the y-axis, so the y-intercept is where a line would go through. That ordered pair right there x would be a 0, and the y would be whatever number that b is that is right there, okay? So if you have y equals 2x minus 5, or let's say plus 5, then this would be a 5 right there, okay? We're going to do examples in just a second. Point slope formula, that's it right there. When you look at the point, that's the x1, y1. That's how you would label a point to use in here and here. And then this is the x and the y that are kind of these x's and y's. They kind of stay there, and that is the same as the slope, okay? It's just another form to put your information in to find the slope-intercept form, kind of on the way to there. Another one you can use is the slope formula if you're not given the slope. So you labeled 2 points this way and put them into this formula. That will get you the slope, so you can put it in here, which you can then turn into there. Okay, that's kind of the process there. All right, so let's practice this stuff you got taught before, hopefully. It says convert into slope-intercept form if not already given, then identify the slope and the y-intercept. The whole point of the slope-intercept formula is that if you have solved for y and it's on one side by itself, that means this right here is the slope, or the m, not the x part, just the numerical coefficient in front of the variable x. That's the math terminology for that. That -2 is the slope, all right? And then right here, including the sign in front of it, is your y-intercept represented by a b, okay? So this next one is in standard form, so you can't just glance at it and see what your slope and your y-intercept is. It has to be converted from a standard form to a slope-intercept form. So that means we want to solve for y to get a lone and on one side. So first thing we want to do is move the x term to where it belongs on the other side. And make sure you shove over, this is going to end up being part of the b, so you want to move it over. So 2x minus 5, right? Then you need the y by itself to be in slope intercept form. So if you divide, you're going to get 2/3 x. Remember, leave things as fractions, please. No mixed numbers. So this is going to be y equals 2/3x minus 5/3. That's okay to have fractions all over the place. Slope is 2/3. That's the number in front of the x, the numerical coefficient of the x. Do not include the x in your slope. All right, and then the y-intercept in this case is -5/3. Okay. This one is also in standard form. Move the 2x over. Oops. -y equals -2x minus 5. People drop that negative. That's not yours to drop, so you need to convert that to a positive by dividing by, remember there is a -1 in front of that, so let's remove that negative by dividing that through. So this -2 over -1 is a positive 2x, -5 over -1 is a positive 5. Therefore my slope is a positive 2 and my y-intercept is a positive 5. Okay. The next one, this one in here, is in point slope form. So right there is my slope. Okay. But just by looking at that, you can't see your B, your Y-intercept. So let's convert this. So that means process this distribution here and here. All right, and then move this number over to be part of the B over there. That's isolating Y on one side. So that's 2x minus 5. So that's my slope and that's my B. So B is a negative 5 for that one. Okay. And then we're going to go practice with the slope formula. 2 points. When you're given 2 points, the only thing you can do is find the slope first. And then it says to also state whether there's positive, negative, 0, or does not exist, which is also a vertical line. Okay. Some of the slopes go like this. That's a positive. Some people call that up the mountain. Down the mountain is a negative. Positive, negative. That's a negative direction. Flat across is a 0 slope, and then off the end is a does not exist slope. Okay, so that's the horizontal, and that's the vertical slope. Okay, horizontal lines begin with a y equals, as do the negatives and positives. The vertical lines end with begin with an x equals. Okay, just a little tip on that one. All right, so when you're given 2 points, label them that way. We decided this was point 1 and that's point 2. So you want to put it in the slope formula. Up here is that formula, right? So y2 is a negative 3, and in the formula has a negative, and then y1 is a negative 5. So make sure you get all those negatives, okay? The points are negatives and the formula has a negative in it. So put them all in there. And then 1 minus 0. So a negative negative is a positive 5. So negative 3 plus 5 is a 2 over 1, which should be a final of a 2. Okay, which is a positive 2. So it's a positive slope. So on the graph, somewhere it's going to be in the positive direction. So that means it'll go up the mountain. Okay. Let's see. So this one's going to be 4 minus 6 over negative 2 minus 2. That's negative 2 over negative 4, which is a negative over negative is a positive half. Okay, so that's also a positive. It's just not as tilted, right? There's less of a slant. That's all that means, but it's still positive and goes up the mountain. So whereas this might be a 2, that might be a half, but it still goes up from left to right, okay? All right, this one would be 5 minus 5 over negative 4 minus 1. 5 minus 5 is 0. Negative 4 plus a negative 1 is negative 5. That is an actual 0, so that's a flat across the horizontal line. Okay, so that's a 0 slope. That's, by the way, that's m equals 0 for a 0 slope. And notice that the y's are 5. So the equation of this line would be y equals 5. Because the slope is 0, the x is missing from the equation because that'll make it go away. So your equation would be y equals 5. Y is always 5, and the x's will change to get a line that looks like, let's put this on a graph, that it's going to go across at the 5. Okay? So let's see, this one would be 3 minus 0 over negative 3. That's just for m. I should be writing that in there. Negative 3 minus a minus 3. So that would be 3 over, that's plus 3. This is 0. So 0 divided by nothing, you're not allowed to do. It's an undefined item. So mom calls that a does not exist slope, right? Because 0 is already taken. So the one that goes straight up and down, the line, equation of the line is going to start with an x equals, and notice the x is a negative 3. So that's over here. It's going to go up and down in a vertical direction over a negative 3. Okay, so that's a slope that doesn't exist, whereas this is a slope that's 0. Okay, hopefully that's all coming back to you. Let's see, equation of the line, determine the slope of the line that would be parallel to the line. What what do I need to know? I need to know that parallel slopes have this same slope. All right, so looking at this in standard form, I can't see what the slope is, so I need to turn this around by solving for x, getting x alone on one side, and putting it in slope-intercept form. Y equals negative 2/3 x plus 5/3. So the slope for this line is m equals negative 2/3. So the slope of the line that would be parallel to that line would also have a slope of negative 2/3. Okay. This equation is in point slope form, so we can look right at it and see that m in this line, the slope for this line of equation is a negative 5. So therefore, a line that would be parallel to it would have a slope of a negative 5. Okay. This one over here, it says determine the slope and the y-intercept of the line given the solutions or ordered pairs, the solutions to the line. So when you have a linear equation that's 2x plus 5, a solution to it, or the ordered pairs that would work, would be anything that would make this equation true. So if you put in, let's say you put in a 1 for x, okay? If you put in a 1 for x, it's 1 times 2 is 2, plus 5 is 7. That means y would be 7 if x was 1. How about 0? If you put a 0 in for x, then 0 times 2 would be 0, plus 5. 5 would be, y would be 5 if x was 0. So they did this here, okay? And they want to know what equation would have these as ordered pairs that are solution to the linear equation, okay? One thing you can notice is that the y's are going up by 3. As you go down this little column, they're going up by 3, okay? And then over here, the x's are going up by 1, okay? So that means the y's are changing by 3, and the x's are changing by 1. So one of the definitions of slope is the change in y over the change in x. That would be 3 over 1, or the slope is 3. All right, what's another way you can do that? Another way you can do that, these are ordered pairs. Negative 2, negative 4 is an ordered pair that's the solution to this line. So is a negative 1 and a negative 1. So you could use the slope formula to solve. Negative 1 minus a negative 4. Probably should have picked some of the ordered pairs that weren't negative, huh? Negative 1 minus a minus 2. That's going to be a positive 4 and a negative 1, so a positive 3. A positive 2 and a negative 1, so a 1. So that's another way to prove that this slope is 3. Okay? Now, ordered pairs can give you the slope, but which ordered pair in here is a b? How do you, when you look at the y-intercept form, this 5 is a b, okay? B's are written that way with a 0 and a 5. That means ordered pairs that are y-intercepts have a 0 for an x. So right here is your b. Pardon me, is the b for this problem, or just 2, okay? So the m is 2, and the m is 3, and the y is 2. So the formula for this is y equals 3x plus 2 is the line that this data comes from, okay? I know that's a lot, but that's a review of all Chapter 2 information in the beginning of the chapter, okay? We'll do the next on the next slide.